So hello everyone, good evening, welcome back to our channel. And yes, from today itself we are starting with the physics section, and in this physics part we are going to discuss all those topics which are very important, and not only physics, we will also complete the biology and chemistry section as well. And this series that we are starting today, on every Friday, that is after completing 3 or 4 topics, we'll have those questions which are important from examination point of view, and also we'll include the most expected questions as well. So I'm talking about the free PDF that is I'm going to share to you. So free ebook will be available on the week's ending, and before that class in which we are going to discuss the 100 to 200 important questions, we'll take these topics which are very relevant with your examination. So let's start with the topic. So the topic that we are going to discuss today is the scalar and vector quantities, which is one of the important topic from the examination point of view. So what are scalar and vector quantities? Let's understand about it. See, first of all, if I talk about the scalar quantity, what is it? So scalar quantities are the ones that have just the magnitude, only magnitude is there. But if I talk about the vector quantity, it has both magnitude and the direction. So let's say I'm talking about distance. So if a person says that I need to, if I'm moving from point A to point B, and then from point B again I move to point A. Let's say from A to B, that's the distance of 5 km. And if a person travels from A to B and again from B to A, he comes back. So we'll say that the total distance covered was 10 km, right? Here, there's no issue of the direction where you are going. It only means that's what's the total path traveled. So if we are talking about just magnitude, that is the scalar quantity. But let's say the same question, if I travel from A to B, which is 5 km away, and again from B I came back to the point A. So now if someone asks me, so what is the total displacement that you have covered? So this time I'll answer the total displacement was of just 0 kilometers. Why? Because initial point and final point is same, which means yes, in the displacement concept we are using direction as well. So if directions are involved, we'll say that's a vector quantity. So the first example that I've given you, that's related to displacement. So displacement, velocity, acceleration, force, weight, moment, they all are vector quantities. If I talk about the scalar quantity, so yes, distance, speed, time, mass, temperature, pressure, kinetic energy, gravitational potential energy, work done, power, they all are scalar quantities because they only and only have magnitude there. So the basic idea is clear, but still we have some doubt in direction. So how we can link it? So do not worry, I have an animation to explain you here. So let's start with the animation so that you'll get this concept clarity. Okay, so starting with the animation, guys, let me take it here. Okay, so let's understand about the scalar and vector quantities. So here we have two bulbs, right? And if I talk about current, so what do you think? Current is a scalar or current is a vector quantity? What should be your answer? So I want your answers in the comment section so that I can easily make you understand this. See, when direction is involved, we'll say that this particular quantity is vector quantity. If direction is not involved, that's the scalar quantity. So for the current, we need to go with the basics first in order to understand whether the current is scalar or vector. So let's start with the animation now. So guys, let's say after the selection, you all came, and as per promise, I'm going to give you the party after the selection. So after the selection, I called you that you guys have to come to Agra, right? So we'll have party also, and we'll visit Taj Mahal as well because Agra is my hometown. You all came to Agra, and now you were at one of the location in where at which there were 4 different paths. Let's say you are in the center of it, and you are asking me, so where we have to go? And my answer was, do one thing, just travel 5 kilometers. Now you will be in doubt. So 5 kilometers where? North, east, west or south? So you cannot travel at that time because you need the specific direction as well. Only the magnitude will not solve the problem here. So if I talk about just magnitude, distance was its example, and which is a scalar quantity. But here I need to tell you, yes, you have to come 5 kilometers, but in the east or west or in north or in south direction. That means along with the magnitude, I need to give you direction as well, right? So here are the commands. Here, see, if I'll talk about 5 km north, you will move 5 km in the north direction. If I'll say just travel 5 km in the south, so you will move 5 km in the southern direction. Similarly, if I'll tell you, just do one thing, travel 5 km in the east, you will move 5 km in the east. And if I'll say similarly 5 km in the west, so you'll move 5 km in the west direction. That means in this condition, I am giving you two main things. What is that? So I am telling you the magnitude also, and I am giving direction as well. So that's the example of a vector quantity. See? So here we can link it with the displacement, where we are including the magnitude with the direction. Still, do not worry. I have more examples related to it so that I can make things very easy. First of all, the directions which I was talking about. So see, if south, we'll go with minus j. If we are talking about east, we'll go with plus I. And if it is west, we'll go with minus I. So I minus I, j minus j, they are going to tell you about the direction. And this we have studied in our 11th standard, right? So I'm giving you some commands. So here, the first command is move 10 km to the north. 10 km north, there was the movement, that is 10j. Move 3 km to the south, that is minus, so that is minus 3j. Then move 1 km to the north, plus 1j. Move 8 km to the south, minus 8j. Okay, 2 km in the east, plus 2i. And the final command is 3 km to the west, minus 3i. So this is the question which we can link with the reasoning as well. In the reasoning, these type of questions are asked. So guys, what is the final position? So you'll say it's 1 km west of the origin. Here, since direction is also involved, we can link it with the vector quantity, and that's what real displacement is. So what is the total displacement? If I'll just try to calculate them, by adding all the components, I'll have minus I as the answer, and that's the final point. But this was about displacement. What about distance? In the distance, we'll not include any direction. So that will be the total path. So that's path length, that is 10 plus 3 plus 1 plus 8. Then, one second, I guess it is paused. Yeah. So here, 10, 3, 1, 8, then 2, and finally the 3. So the total distance will be 10 plus 3 plus 1 plus 8 plus 2 plus 3, that is 27 kilometers. So 27 kilometers is the total distance that is traveled. So what we have understood, if I talk about a scalar quantity, it only includes the magnitude, and here mass, density, speed, distance, they all are under same category. What if I'll talk about vector quantity? So vector quantities have the both magnitude and the direction. So displacement, velocity, force, they are the examples of vector quantities. So this part is clear, right? So I have some more examples to explain you. See, from this animation, it gives us clarity. See, what is current? So if I talk about electric current, that's the flow of charge. So the flow of electrons. So in this condition, we can say direction of current is given. So direction is involved. And here we are talking about the electron flow direction. Also we are talking about magnitude. So direction plus magnitude. So current should be vector, right? But no, current is not a vector quantity. Why? So this example will give you the clarity. Let's say we have a 10 kilogram of the weight here. I am applying 10 Newton of the force here. 10 Newton of the force here. So what will be net force? 20 Newton? No, it will be 0 because the body is at rest. Since the body is at rest, so if I talk about the vector addition, it's plus 10i, it's minus 10i, that is going to give you 0 value. So yes, is the same condition there with the current as well? No. Here 10 ampere and 10 ampere, will it be 0? No. In this condition, this vector addition is not followed. Here 10 plus 10 will be 20. That means it is following the algebraic sum. So whenever algebraic sum is followed, that is, it is not following the vector of addition, we will say that particular quantity is scalar. So this gives us clarity. Guys, you must remember this. And it's very important to understand whenever someone is talking about the scalar quantity. So we have few conditions, that is, first of all, only magnitude, only magnitude, no direction. So these two are the basic conditions, but third one is more important. So the first point, the second point, and the third point is it must not follow, or I'll write doesn't follow vector addition. Doesn't follow vector addition. At that time, the quantity will be considered as scalar. So many of the candidates have doubt here, and with this animation everything is very clear that we can take the example of current also. So I'll write it for you. So you need to remember one more example, and that's current. So current is actually the example of scalar quantity. Is it clear, guys? And that's very important, very important, because most of the candidates think, sir, how is it possible? So I guess now this part is also clear. So if you have any doubts or any queries, you can just let me know. Is it clear? Perfect. So now I'll just conclude everything. So what we have discussed till now. So if someone asks you about the scalar quantities, so it will be point number 1, only magnitude. Second, no direction. And the third one is it should not follow, that is, doesn't follow vector law of addition. What is that? Doesn't follow vector law of addition, or I'll just say doesn't follow vector addition. That's done, right? And if I talk about vector, so what is it? So vector quantities includes magnitude also, direction also, and also they'll include the vector addition. So this is all about the scalar and vector quantities. I guess you have understood it easily with the help of this animation, and for these type of videos will regularly be up. And one more thing, guys, about these sessions which we have started today. So today we have discussed the scalar and vector quantities. In the next class, we'll be discussing electricity, and day after tomorrow, we'll discuss magnetism. So these will be the theoretical classes which are very relevant with the examination. And after these theory classes, the combination of all these sessions will be taken on the 4th day, where we'll have the test. And this test will include the most important 100 questions, and in those most important questions I am preparing the ebook also for you people, so that you can get the content that is very important for the examination, and you need not purchase it because that ebook will be completely free of cost. So I want in the comment section, how do you feel this concept is? If you feel like it's a good concept, we can continue this series for the science first, then we'll continue with the other parts of the GS as well. Yes, I'll include all those questions which were there in the previous year paper. Also, I'll include the questions which are most expected, so that everything will be covered. And yes, obviously, I'll go with these type of animations so that everything gets clear with these animations, because animations actually makes our things easy, right? So here, that's all from my end, but still I'll just show you that all these sessions are aligned in a, so one second. So guys, you can just go to the Oliveboard's website. One second. Yeah. So guys, if you want to purchase any batch, you can just go to the Oliveboard's website. You can just click on it, and here there's an offer that is going on, 2x validity plus 40% off on all the SSC test subscriptions. You'll get full length mock test, PYPs, topic detailed typing test, detailed solutions, and all. So you can enroll now from clicking this option. Also, on the YouTube, where you are watching this session, so first of all, just like this session and just subscribe our channel. So here you'll get my sessions daily at 5 p.m. So what do you have to do? You'll just go to the live section. Here you'll find that I have already asked the team to prepare my all the lectures. This is the final lecture on which I'll just give you the free ebook. Also, the chapter that is magnetism we will be discussing here. Tomorrow we have electricity that we are going to discuss, and in this way we will complete the theory in the first 3 days, and finally we'll go with the test. So that's all from my end. Tomorrow please meet sharp at 5 so that we can finish electricity tomorrow. And yes, again I have animation tomorrow as well. Till then, please take care. Bye bye guys. All the very best for the examination. We'll meet tomorrow sharp at 5, and please collect all the data so that you can revise on the final day when questions will be discussed. Thank you guys. Bye bye. Take care. Jai Hind.